Great. In case you were not here on Wednesday when we went over section 113, I'm just going to quickly go through 122. I know many of you did not get through the area as well, but I'll show you perimeter. So I'm choosing to do figure A. So if you want to follow along, I know some of you had different figures, but it's the same kind of approach. So if we look at figure A, we want to find the perimeter for each of the figures. So again, perimeter being the outside. So we're counting, we have 3, 3, and then each of these things we are counting as well. So 6, 7, 8, 9, 10, 11, 12. So my perimeter for figure 1 is 12. And then if we look at figure 2, we have 6, 6, and then each of these are 2. So 12, 14, 16, 18, 20, 22, 24. So in figure 2, our perimeter is 24. Some of you are realizing a pattern, which is great, but we'll just make sure we keep on going. So again, figure 3, this is going to be 9, 9, and each of these are 3. So 18, 21, 24, 27, 30, 33, 36. And then I don't have figure 4 in front, but figure 4 should end up being 48. Figure 5 is 60. And figure 20 is going to be 240. So again, this is for figure A. Some of you have a different perimeter for each of them. So if we take a look at B, it says graph the perimeter data for figures 1 through 5. So we have this graph over here we can use. Some of you put it on your graph paper, that's fine. So if we go ahead, I can use 1, 2, 3, 4, 5 for my X axis. And then since they all go by 12, so I'm just going to go ahead and go by 12. So 12, 24, 36, 48, and 60. So we can go ahead and graph those. So 112, we have 224, we have 336, we have 448, and we have 560. So I know we talked about this. It's in the shape of a line, so we can answer that it is linear. But we can't connect that, because if we connect it, that means that we have things that are in between. So we have figure 1.5, but that's not a possibility to make, or figure 2 and a third, but that's also not a possibility to make. So then our next question, if we look at C, how does the perimeter grow? Examine your table and graph and describe how the perimeter changes as the row gets bigger. So it grows at the same rate, so it's going to grow at a constant rate. And it'll be linear again. So it's growing at a constant rate. Each of these things, it's just adding 12 to each of those. So then if we look at D, generalize the patterns you have found by writing an equation that will find the perimeter of any size rug in your design. That is, what is the perimeter of figure N? So figure N just means any number figure. So that's going to be something that's important later on. So any number figure. So if we go back to our table, we can see figure 1 is 12, figure 2 is 24, figure 3 is 36. So it's really just taking our figure number and multiplying it by 12. So if you had 14 in figure 1, we know that it would just be 14 times that. So our perimeter is going to be equal to 12 times n. So that's the formula that I can use to be able to find our perimeter. So the next thing is looking at area. So I'm going to do the same thing with area. So looking at 123. So it says analyze the area. And again, I'm still going to use figure A, so yours might be a little bit different. But it says now analyze how the area changes with the table and graph. Make a new table like the one below to organize the information about the area of each rug in your design. So if I look at figure 1, now we're not talking about the outside, we're talking about how many blocks. So 1, 2, 3, 4, 5, 6. So our area is going to be 6. And then if I look at figure 2, 4, 8, 12, 16, 20, 24. So there's 24. And if we look at figure 3, we have 9 in each of those. So 9, 18, 27, 36, 45, 54. And we have this continual pattern. So figure 4 and figure 5, I got to quickly look. So if we, sorry about that, if we count the blocks for those in figure A, this should end up being 96, and then this ends up being 150. So you can count yours, you should have your number in front, and then that is 2400. Okay, so that is our area table that we can fill in. I'm doing this for figure A. So if you had a different, or letter A, if you had a different letter, it's going to be a little bit different. So in B, on a new set of axes, so I have it right to the next, we want to go ahead and graph. So I can still graph or use 1, 2, 3, 4, 5 along our x-axis, but our y is going to be a little bit different. It doesn't go by the same thing. So it goes up to 150, so maybe we go by 25s. Again, it could be a little bit different. So 25, 50, 75, 100, 125, and 150. So if I go ahead and graph that, 1, 6, just an estimate there, 224, slightly below, we have 354, we have 496, and we have 5, 150. So we can see that actually isn't going to be in the shape of a line. It actually is going to be a curve. So we know from Algebra 1 that that curve is going to be in the shape of a parabola, or half a parabola in this case. So it's an exponential. So what shape is the graph? We can say that this graph is in the shape of a parabola, or parabolic. So if we look at C, how does the area grow? So it doesn't grow at the same constant rate with a linear function. So it's actually going to grow exponentially. So we can say that this is going to grow exponentially because it forms a parabola. So we can go ahead and fill that in. So then in D, we want to be able to write an equation that will find the area of figure N. So this one's a little bit more challenging, but if it grows exponentially, we want to be able to have some sort of exponent. So we still want to use this figure N. So if we figure out, or try to figure out here, if I take figure 1, so I guess let me zoom out a little bit so you can still see the table and see D. So if I look at 1, we need it to be 6. If I look at 2, we need it to be 24. If we look at 3, we need it to be 54. So since it's exponentially, we're going to have an exponent. So if we actually square n squared, so 1 squared is 1, I need it to end up with 6. So I'm going to take and just multiply this by 6. And we'll see if that works for the rest of them. So if I do 2 squared is 4 times 6, that gives me the 24, so it definitely works. 3 squared times 9, and so on and so on. So we can see what that pattern is for that. So 3 squared 9 times 6 is 54, 4 squared is 16 times 6 is 96. So whatever your area of the first one is just going to replace this, but we're definitely going to have that n squared. So that would be the area. So again, growing exponentially there. All right, and I think that is it.